Hello, and welcome to my presentation on implementing Rancher and Kubernetes in higher education. Today, I'm going to talk to you about the journey we went through at Stephen F. Austin State University to implement an enterprise-ready Kubernetes environment. So I'm going to start with the selection. We reviewed a number of products, and we went through that review process and ended up selecting Rancher. From there, we went through an onboarding process with Rancher called a quick start. During that quick start, we had an implementation, and I'm going to review all of the steps of that implementation. And then we're going to get into our continuous integration and continuous delivery, which is an important part of our Kubernetes journey. After that, I'll walk you through a real-time demo of our environment and the processes we use. And I'll end up with a slide on roadblocks and lessons we learned along the way. So I hope you enjoy it. First of all, my name is Travis Killen. I'm Assistant Director of Enterprise Systems here at Stephen F. Austin State University, and I'm the only one speaking to you today, but I'd like to recognize the efforts of Tyler Davenport, who's a system programmer on my team, and he was the technical lead on the project, and certainly I could not have done this whole project without his work and leadership. So for the selection, we looked at 3 different products, including VMware Tanzu, SUSE Rancher, and Red Hat OpenShift. And I'll start with Red Hat. We have a relationship with Red Hat, so that was one of the reasons that we looked at their software. And it's a great enterprise Kubernetes solution. However, we found a lot of complexities in getting our POC stood up. In fact, we never really got it off the ground due to the complexities. And if you don't know about Kubernetes, one thing that you might learn is that there is a lot of complexities to the different solutions and systems. So while we weren't able to get that one off the ground, we looked at some others as well, including VMware Tanzu, and we had a little bit better luck with them. We did already have a relationship with VMware, and we found out at the end of the POC that the cost of VMware was certainly appealing. So, but part of the problems that we had with them was, again, the complexity around the POC. It was it had a lot of different components and parts, so we found ourselves switching from one platform into another platform to do all the management and Kubernetes management. And finally, that brings us to SUSE. So we had a very easy time getting the POC stood up. In fact, it was just one command in our Docker testing environment to get the Rancher environment stood up. It had a great user interface, and they offered a good onboarding solution for us called the Quick Start. Another thing that we liked about SUSE Rancher was there was no vendor lock-in, and a lot of the processes that we went through are Kubernetes native, so they would apply to any enterprise Kubernetes solution. We also found compatibility with our VMware environment and our Red Hat environment. The only con was that we didn't have a relationship already with SUSE, but we managed to get that through our purchasing department without any major issues. So let me tell you a little bit about our onboarding experience. We did the SUSE Rancher 24-hour quick start, which was a project management engagement. And that started with a supportability review to make sure that we were starting with an environment that was ready to be supported. That environment was built on top of our POC, or proof of concept, from the previous slide. And they went through our engagement planning so that we would know the expectations so that the SUSE team would know our expectations, and we would have a good understanding of the statement of work for the SUSE team. And in that engagement, we went through all the configurations. I'm going to run through a lot of these quickly now, but they're going to be discussed more in depth in our implementation. So basically, during the quick start, we went through our environment review, and we talked about our image registry and how we were going to access and maintain our container images. We went through our vSphere integrations because we knew that we would want to leverage our vSphere environment. We went through a load balancer installation to make our containers highly available. And we went through our backup architecture so that we would know that we could, in a disaster scenario, we could get everything back up and running. And finally, we went through some production readiness checks. After we got all of those core configurations done, we went through and looked at our continuous integration and continuous delivery, or CI/CD, which I've come to learn is a very important part of the Kubernetes journey. In that, we talked about our manifest, which is where you store app-specific information about your container deployments, and our code repositories where they live, including the pipelines that automate processes, and finally Fleet, which helps with the continuous delivery and delivers those apps into test and production. So the first part of my presentation, I'll call the implementation, or the meat of the presentation. This is the most important parts of it. We have our Rancher environment set up with a local cluster and 2 downstream clusters. The local cluster is a 3-node cluster, and each node in that cluster is running the control plane, etcd, and worker roles. These are required for the basic functionality of Rancher, and we don't run any workloads on these 3-node local cluster nodes. The 2 downstream clusters is where we run our workloads or apps, and each one of those is made up of 3 control plane and etcd nodes and 4 or more worker nodes. So the apps are actually running on the worker nodes, and the control nodes are used to schedule the container delivery and Rancher administrative processes. We do have taints on the control nodes so that we don't end up with any apps or processes outside of Rancher running on those control plane nodes. You could see a picture in the bottom right or on the right side of Rancher, the Rancher interface, and our 3 clusters. Next, I'd like to talk to you about our image registry. The image registry is where you store your container image builds. We started out with Docker image registry, which was really great. It's a lightweight registry, and it's perfect for getting started. But what we found is we were working a lot in the command line, and there were certain features we were looking for that weren't offered in the Docker image registry. So eventually we looked at Harbor, which has a graphical user interface, and it's a more robust image registry. It can do things like role-based access control, so we could get our programming team or others into the environment so that they could see their container images, and also provide some automations, robotic automations for building the images and doing security scans of the image. So we ended up using Harbor in our environment, which has worked well. During our implementation, we knew that we would want to integrate with VMware, which is our VM platform. So there were several pieces of that I'd like to go over. The first of which is the node drivers. So in Rancher, you'll find node templates, and we have 2 templates, one for control nodes and one for worker nodes. Now these are using the same template in VM template in vSphere. However, we have different configurations, including memory and CPUs on those nodes in Rancher. So you configure the node template in Rancher, and that spins out the VM template in vSphere. We knew that we would want persistent storage to be available for our nodes, and that's where the vSphere CPI and vSphere CSI come into play. The cloud provider interface, or CPI, that maps information about vSphere back into the Kubernetes API. That allows Kubernetes and vSphere to talk to each other. Also, we had to install the cloud storage interface, or CSI, which actually provisions the vSphere volumes in VMware. On the right side, you can see those storage volumes showing up, those PVC volumes showing up as native container volumes in VMware. So that's a really neat plugin. the the CSI will provide us with persistent storage on the nodes, and it'll provision volumes as cloud native storage in vCenter. These are just apps in the Rancher app store that we can download and configure and deploy, which we did on our implementation. We knew that we would need a load balancer. Load balancer is important for providing highly available services. And we use F5 Big IP in our environment. And so we looked at the integrations that the Big IP has with Rancher and Kubernetes. And we did have some success using the F5, especially with node ports. So we could get a service up and running. We had some node ports available. We would load balance those in the F5, and we could switch pretty well between the different nodes using the F5 as a front end load balancer. However, once we started automating certain aspects of spinning out new nodes and the complexities of the solution, we found that what we were doing was having to go into F5 and update our node ports regularly. Now, I do know that there is probably some great solutions around this for F5 in general, and certainly a lot of options available. However, one of the things that our quick start support uh, representatives told us was that we might want to look at KubeVip. KubeVip is a Kubernetes native solution, and it's installed with a simple manifest. It creates a highly available IP for each for the cluster, or for each cluster, and it won't break when you provision nodes. So it was basically an easier solution for us, and it worked pretty well. It works by watching for load balanced services and provisions an IP for those services as soon as you spin them out. Our backup architecture was something that we wanted to make sure was planned for carefully. So we talked to our representatives about how to back up the Rancher environment and what those backups would look like and how to do restores. So what they walked us through was creating etcd snapshots, and we sent those snapshots to an S3 bucket on our Isilon local storage clusters. And we use the Rancher backup operator in our local cluster, and that backs up our Rancher settings. You can use those backups to migrate to a new cluster or to restore an existing cluster. It does grab the manifest from the local cluster, and it restores connections to downstream agents. However, one thing that it does not do is it does not grab persistent data. So that's something to be aware of as you're organizing your backup architecture. For us, for our environment, what we decided to do was we have a Docker environment that sits outside of our Kubernetes and Rancher environments. And on that, we run a product called Portainer. And we run that on a VM. We've named that VM Black Pearl. And that VM has a backup of our RKE, or Rancher Kubernetes engine, and our cluster state. The persistent data that we have in our environment is stored or replicated to Black Pearl, and then we back Black Pearl up with Veeam. We make sure we get our manifests, our cluster state, our GitLab, our source code, and images, store all that information on Black Pearl, and then we back that Black Pearl VM up with Veeam, so we have an image backup of all that information. I'd like to mention that we did look at Kasten, which is a Kubernetes native solution for backing up containers, and it does allow the backup of persistent data. We have been testing this and have good results so far, but it's not a product that we have purchased quite yet. So I've talked to you about the implementation of our environment, and now I'd like to talk to you about the continuous integration and continuous delivery, because this is what I'll call the potatoes of the presentation. We already had the meat, but in order to get the full meal deal out of Kubernetes, you really need to have conversations around CI/CD and look into the automation that they can provide you. So when we were looking at our CI/CD solutions, we evaluated a couple different products, including Jenkins and GitLab. And Jenkins was great. It has a lot of third-party plugins, and it has a lot of features that are available. If you already use a Jenkins for your environment, this might be a great solution. It does pipelining and some other things, and it's free. One thing that we weren't wild about is that it is not a Git repository. So we were also looking for source control, but you couldn't find that natively in Jenkins. Whereas GitLab is a Git repository, and it has a lot of the functions of Jenkins, including pipelining and automation built in. It also had some better documentation. So we really liked the web interface. One of the features that we like to use is the web IDE for quick code edits. You don't have to have a full-blown IDE to commit your code to the Git repositories. And it is free, but it has more limitations around it. You'll have to get a paid version to unlock all the features of GitLab, but we have been able to work with the community edition. So I'm going to dive a little bit deeper into GitLab and our configurations there. In our GitLab, we're working with multiple code branches, and we have different branches for test and prod. This allows us to have a test containers built and spun out into our test environment, and then we end up merging those changes into prod during our change control processes. Our manifests are stored in a .gitlab folder. So every app that we deploy has a .gitlab folder with manifests that store information about the configurations of the app and things like the memory that we want to use, the CPU that we want to use, different information about the services that are required, like load balancers and um, specific information about the app. Our GitLab has pipelines that we use. Those pipelines can build the container image when the code is committed. So that's a neat feature and provides the automation. It automatically updates that container image into our image registry harbor. And the last part of the pipeline for us is to update the manifest with a new container image tag. That allows Fleet and other continuous delivery platforms to deliver that image out into the Kubernetes environment. So I'll talk to you about our change control processes a little bit. So once a code change is committed in test, there's no change control required. We just spin that test image directly out into our test environment. However, when it's ready to move to prod, we require a change control request, and that initiates a process that moves the code changes into production. Another thing that we do in GitLab is we schedule rebuild of container images just to make sure they are updating regularly and securing them against new vulnerabilities. That's all done with a scheduled rebuild of the container image. So Fleet is a SUSE Rancher native continuous delivery product. And the way it works is that it watches the manifest for changes in the GitLab repo branches. So once a manifest changes, it looks for that change, and once it sees that change, it redeploys that image. And in our case, the main change that it's looking for is a change of an image tag. So as soon as it sees that image tag change, then it knows that the deployment is ready to be delivered. Now we have separate deployments for our test and prod clusters. So when it sees the change in test, it deploys that container to our test environment. And when it sees the change in prod, it delivers it to our prod environment. So I'd like to go over the entire CI/CD workflow. This is kind of bringing everything that we've talked about together. So from a programmer's perspective, they start in their IDE to develop their code. And once they create their code or make changes to their code, they push those changes to our test environment. There's no change control required for our test environment. So the pipeline is automatically kicked off, the image is built, and the manifest is updated. Fleet detects those changes in the manifest and deploys that app to our test environment. They can repeat that process as many times as they need to to develop and test their code. Once they're ready to push their code into production, they submit a change control request. At that time, we go through our typical change control processes. And once the change control has been approved, we have administrators that will merge the code from test to prod. Once the code is merged or the branches are merged, the the pipeline is kicked off or the processes are kicked off and the manifest is updated. Fleet detects the change in the prod manifest and updates the deployment. So now I'd like to give you a real-time demo of these processes in action. I'm going to start in my IDE, and I've got an app open here, and I'm just going to make a small change to say, welcome SUSECon 23. I'm going to save those changes, and we can see that my IDE has detected the changes and they're ready to commit. I'm going to type commit message, commit the code, and sync it to the repository. Once I do that, I can come out here and I can see my test app. I know this is our test environment. And this is the way it looks right now. I can come into our GitLab and I can see the pipeline is running. So right now it's building the container image and pushing it to Harbor. I can see that the next step is to modify the manifest. In Harbor, I can see we've had a build at, last build was at 1040. So that's about 50 minutes ago. And the tag was 48. Once the container image is built, it will get pushed here. Okay, so we can see that it just got pushed right now. And we've updated the container tag to 49. So at this point, Rancher will detect that change. And we could see that in our test environment. Oh, we just saw that it changed. And it is terminating and now running the new app with the changes. So I will come back over here and we see the changes made to our test app. And we can again see that we're in our test environment and not prod. So in our production environment, we see the same app and it has no changes. We can see that we're in our prod environment. So at this point, I'm ready to push those changes to prod. And I'm going to do that. Normally, the programmer would submit a change control request that would have to be approved. Once it's approved, I can create a merge request, and I'll merge our test branch into our prod branch. We're going to compare and continue and create the merge request and merge the code. Back in Rancher, we could see our app here is about an hour and a half old, and it is detected the change in the manifest and is now redeploying the app. And it looks like that has finished, and the new app is running. So I'm going to come back out here to our prod environment and refresh, and we could see that the code changes have now been moved to prod. All right, so hope you enjoyed that demo. Now I get to talk to you about roadblocks and lessons we learned along the way. There were certainly a lot of challenges that we faced. The first one I'd like to mention is the learning curves. You have to have a lot of knowledge about a lot of different systems, including Linux, networking, infrastructure, storage configurations, Kubernetes, and Docker. So if you're not familiar with a lot of these technologies, then it's going to be a difficult journey. One thing that we did was take the training on the 2-day Kubernetes training and the 3-day Rancher training that was a package provided by SUSE. That worked pretty well to get a lot of our technicians, at least engaged and started on the Kubernetes journey. I would recommend, depending on the size of your deployment, that I would think you would need at least 2 to 3 dedicated technicians for a journey like this. It is a lot of work, and even for a small environment like ours that's just getting off the ground, you're going to have technicians that are dedicated to this and ready to learn and work through all the challenges. There are just a lot of complexities during the deployment. Don't underestimate them. A 24-hour quick start may not be enough time for you. I think they offer an 80-hour professional services engagement as well, which, depending on where you are in your journey, may be more appropriate for you to schedule more time with the professional services team to get this off the ground. I would recommend that you leverage your support contract. We have had a lot of luck using support and getting some hands-on time with technicians and knowledgeable people. They respond in a timely manner, and they always are very helpful. A little bit of advice: push forward. Don't get scared off. It is complex, and there's a lot of challenges along the way. But if you push forward and try to jump through the hoops and get over the bumps one at a time, I think you'll find that the automation that you can achieve is just amazing. One of the things that we didn't realize during our journey, a lesson learned, was the importance of CI/CD. CI/CD really streamlines the nature of the operations, and it requires a lot of forethought and foresight. There's a lot of nuanced complexities and options available for CI/CD. So look into these and don't underestimate the complexities associated with CI/CD. Once you have a good plan in place, I think you'll find that it leads to huge time savings with a good CI/CD methodology, a lot of automation, and a lot of less time for technicians to deploy apps. So thank you so much. I hope you enjoyed my presentation, and enjoy SUSECon.